Okay, grade 8. This is our last lesson in chapter 11. So we are doing lesson 6, trapezoids and kites. For this lesson, you have to remember even lesson 5. Wait, I think lesson 5 also you have to remember. We're going to do Pythagorean. Okay. Alright, so you have to remember these chapters. Chapter 5, that was in your term 2 book, and chapter 10 and 11. You will need the information from these chapters to be successful in this lesson. Okay? You also must know how to read correctly. You must know how to use vocabulary correctly. I keep saying, with math, if you read incorrectly, 9 out of 10 times your answer will be wrong. Okay? There is no guessing. You have to know why your answer is correct. You also have to know why your answer is wrong. You have to know everything. The correct use of vocabulary, how to label angles, how to read angles correctly. So many things are important over here. Okay. Now, what is a trapezoid? It is a quadrilateral because it has 4 sides. You also have to know if you add all the interior angles, you should get 360 degrees. This you know. Alright? It has only one pair of opposite sides that are parallel. Whatever I have underlined is very important. Please don't read incorrectly. I said opposite sides. I said parallel. Okay? I said only one pair. Non-parallel sides are called legs. The parallel sides are called bases. The legs are transversals to each base. Okay, so if you forgot what is a transversal, you go here, chapter 5, and look. You should remember this. The legs are transversals to each base. If the legs are congruent, then the trapezoid is called an isosceles trapezoid. So I drew 3 of them. I labeled. So the bases are the ones that are parallel. How do I know? Because of the arrows. Now if these are bases, the other ones are legs. It doesn't matter. I can put base 1 here, base 2 here. It doesn't matter where you put the numbers. But just know this is a base and this is a base. And this is a leg and this is a leg. Okay? The same thing on this picture. Now, if you look at this picture, it is different from these 2 pictures. Why? Because we put the congruency marks, the tick marks that show congruency. So we are saying AD is congruent to BC. Now, the isosceles trapezoid has more properties that you need to know. We have said these are the bases and these are the legs. Okay? I want to do something here. I'll rewrite later when I finish explaining this. So, an isosceles trapezoid, this one, trapezoid A, B, C, D is an isosceles trapezoid because the legs are congruent. The legs names AD, line AD is congruent to BC, or line DA is congruent to CB. Also, you should know that the consecutive angles on the same base, not on the legs, on the base, are congruent. That means base 1 has angle A and angle B. See, angle A and angle B. So if I write A degrees here, I should write A degrees here. If, angle D and angle C are on the same base. So therefore, if I write B here, I should write B here. So if this is 30, this is 30. If this is 20, this is 20. You have to use the same number, okay? You can't write 20 here and write 14 here, no. If this is 20, this is 20, okay? Now, in an isosceles trapezoid, the angles made by the legs are supplementary. Okay, the angles made by the, but it's in all. I don't think it's only in isosceles. Even here, this angle plus this angle will be supplementary. So here we should also write more equations. So I can write A plus B should be 180 degrees. So also the consecutive made by the base are supplementary. But what is special about this one is the consecutive made by the bases must be congruent. Here they don't need to be congruent. Here there can be different numbers, but this angle here, angle C plus angle D, should add up to 180. This we know from quadrilaterals. Consecutive angles in any quadrilateral should be supplementary. You should know that, okay? Angles that follow each other must be supplementary in a quadrilateral. Now, we should know that how to find the area of a trapezoid. Area equals to half base 1 plus base 2 times the height. This is the formula to find area of any trapezoid. So half base 1 plus base 2, and then you multiply these three numbers, half, this, and this. Okay? Remember, your height has to be perpendicular. It's be the one that forms 90 degrees. The question will tell you. And if you want to find the perimeter, you add all the sides. So perimeter equals to leg 1 plus leg 2 plus base 1 plus base 2. If you add all these four numbers or four values, it gives you the perimeter. If you multiply the height, first you have to add the base 1 and base 2, and then multiply by the height, and then multiply by 1/2 to give you the area. Okay? So C plus D, angle C plus angle D should give you 180 degrees. If this is 90, this should also be 90. So 90 plus 90 is 180. And then 90, then you find this too, depending on the question, okay? But you've known that this is important. On the same base, if you are an isosceles, then you are congruent on the same base. All right, we continue. Now, the diagonals of a trapezoid that is isosceles. So the diagonals of an isosceles trapezoid are congruent. Very important information. So we draw a trapezoid DEFG. So this is trapezoid DEFG. And the diagonals, so we did the base. The base is DE and GF. The legs are DG and EF. The diagonals are GE and DF. So this is an isosceles trapezoid because the legs are congruent. So yeah, and then I wrote it like this. An isosceles trapezoid, the diagonals are congruent. Then I wrote my diagonal names and the congruency sign. In an isosceles trapezoid, the base angles are congruent. Then I said A is congruent to B and C is congruent to D. Okay? Then now we need to do the mid-segment of a trapezoid. This is the rule for any trapezoid. It doesn't matter whether you're isosceles or not. As long as you're a trapezoid, you can apply the mid-segment of a trapezoid rule. So, the midpoints of the legs, when connected by a line, this line is what we are calling the mid-segment. Sorry, not the midpoint, the mid-segment. Supposed to be one word. Mid-segment. Okay? Now, in this lesson, on this part of this lesson, you must remember the distance formula, the midpoint formula, how to find the endpoint when you know the one endpoint and the midpoint. So, the distance formula, I reminded you over here, you use the endpoints. The midpoint formula, it gives you the midpoint. So you need the x ordered pair, the x value of the ordered pair and the y value of the ordered pair. And then this one will help you to find the other endpoint. Where you know the midpoint, you put the number for the midpoint, and you know x1, and then you need to find x2. That's what this is, finding x2 and y2. That we learned in chapter 10. Okay? Now let us see what is the midpoint, the mid-segment equation. So we start here. The mid-segment is parallel to each base. So our mid-segment is EF. It is parallel to AB, and it is also parallel to DC. Parallel lines are shown by the arrows. Okay, the legs are transversal to each base. So AD is a transversal because it cuts the parallel lines. It crosses the parallel lines. BC is also a transversal because it cuts or crosses the parallel lines. So what is the name of our trapezoid? ABCD, according to this. How many bases do we have? 2. We have AB and DC. How many legs do we have? 2. We have AD and BC. What is our mid-segment? EF. We have shown over here on the picture. E is the midpoint in AD. So AD, the midpoint is E. So that means ED is congruent to AE. This part is equal to that part. Okay? If F is the midpoint of BC, then BF is congruent to FC. Okay? So if I write 6 here, I should write 6 here. If I write 4 here, I should write 4 here. I did not say their opposites are congruent. That's not what I said. I say this part is congruent to this part. And this part is congruent to that part. Okay? So this number here will be the same with this number. This number will be the same with this number. All right. The important formula. The mid-segment length is equal to the sum of the lengths of the bases divided by 2. The mid-segment length is equal to base 1 plus base 2 divided by 2. According to my picture, EF is our mid-segment. According to our picture, AB is one base, DC is another base, and then you divide by 2. Now, let us see how this looks like in a question. Find the value of x if Qn is the mid-segment of trapezoid LMOP. So, they gave you the trapezoid, it is labeled. You have your first base is x, your mid-segment is 8, and your second base is 14 and 8/10. Then you write your formula. Mid-segment, base 1 plus base 2 divided by 2. You write your names, Qn, LMP, LM plus PO divided by 2. Qn is 8, I wrote it there. LM is X. I wrote it there. PO is 14 and 8/10, and I wrote it there, and I have to divide by 2. So how do I solve? I have to multiply both sides by 2, which I did to get rid of this denominator. So I do the multiplicative inverse. Since we have a denominator of 2, I have to make a numerator 2. Then I divide them, becomes 1. That's why I cross them out. And then I subtract 14.8 on both sides. Colors. And then X is 1.2. Remember? Smaller like that. This has to be smaller than the mid-segment. The mid-segment has to be smaller than base 2. Small, middle, and then like that. As in you go in order. This one cannot be bigger than this. And cannot be bigger than this. So if you're arranging, it's from least to greatest. Or from greatest to least. Okay? You have to remember that. Remember, your line segments will never be negative. Never. You're measuring length. Length will never be negative. It's distance. The distance from L to M must always be positive. Always. All right. Now let us look over here. You've been given this trapezoid, and it is drawn on a coordinate plane. How do I know? Because I've been given ordered pairs. Okay? And they are going to ask me what is the pair, what is the ordered pair for G. That means give the point for G. Give me the X and Y. Find the ordered pair of G. I know that FG is the mid-segment of A, B, C, D. And if FG is the mid-segment, then F is the midpoint of AB and G is the midpoint of DC. And because this is the midpoint, then I will need the midpoint formula. Then I write it over there. D is this, C is this. I label X1, Y1, X2, Y2. I got this information from the question. I have to remember this formula from chapter 10. Okay? So then, since I'm looking for XM, I know X1 and Y and X2. X1 is 1, X2 is 20. I add, I divide by 2, I get that. Y1 is 4, Y2 is 0. I add and divide and get by 2. So my ordered pair is these two numbers. This is for X and this is for Y. And I wrote it over here and I boxed it because this is my answer. Okay? Now let's do the kite. So, what is a kite? It is a quadrilateral. It has two pairs of consecutive congruent sides. Its diagonals are perpendicular. It has only one pair of opposite angles that are congruent. Now, when I said perpendicular, what did I think of? Right angle. And when I see a right angle, I need to think of a right triangle. A right triangle, I need to think of Pythagorean Theorem. Remember these 3 rules we learned in chapter 5? You have to remember them. Because one of them, you will need it to help you solve questions in kites. So when you see kite, remember Pythagorean Theorem. You must use it when you're finding the sides and the length. Any length in the kite, you have to use Pythagorean Theorem. Okay? Now you have kites PQRS. PQRS. Consecutive sides are PQ is consecutive to QR. PQ is also consecutive to PS. SR is consecutive to RQ. And it is also consecutive to SP. Consecutive means it follows. So if I start here SP, I will go to PQ. If I start here SR, I will go to RQ. But it says consecutive. You have two consecutive sides that are congruent. So as you can see, the consecutive sides that are congruent are PQ is congruent to QR, and PS is congruent to SR. That's what it means. You have two pairs, so this is one pair, and this is another pair. Okay? I did not say this is one pair. No. This pair is not congruent. This is a pair, yes, but it is not congruent, even though they are consecutive. Okay? The consecutive pairs are these ones that form the V. This, and they have the same tick marks. Same tick marks, okay? All right. Angle QPS is congruent to angle QRS. QPS, this angle here, is congruent to QRS, this angle here. These two angles must be congruent in the kite. These ones. Okay? Now, there are two isosceles triangles. So the big triangle and the small triangle. This big triangle is isosceles. This small triangle is isosceles. So I have triangle JMK is isosceles because JM is congruent to JK. And I have triangle MKL is isosceles because ML is congruent to LK. Then I have diagonals JL and MK. They are perpendicular. That means where they meet, they make 90 degrees. Then there are four right triangles in a kite. J and M, J and K, M and L, L and K. Those triangles are right triangles. Okay? Now let us answer some question about the kite. This one I wanted us to do together before. Now, the measure of angle BAD is 38. The measure of angle, I guess this is A. Yes. The measure of angle BAD, that means this here. These two angles, when I add them, I should get 38 degrees, according to the question. The measure of angle BCD is 50. So these two angles, BCD, this is these two angles here. This is what? 50 degrees. Then they said BT is 5 centimeters. BT is 5 centimeters. And because this is a kite, this is 90 degrees. Okay? And TC is 8 centimeters. Okay? So, what does the question want us to do? Find ADC. Find ADC. It wants me to find this angle here. That's what it wants. Okay? Now, I know that the sum of angles in a trapezoid is 360. And I also know that this angle is the same as this angle. So what will I do? I will write my formula. Angle A plus angle C plus angle B plus angle D should give me 360 degrees. Angle A is 38 degrees. Angle C is 50 degrees. Angle B is A degrees. And angle D is A degrees because we said they must be congruent. I can use any letter. I can use X. It doesn't matter. 360 degrees. Now, this is 88 degrees plus 2A. A plus A is 2A equals to 360 degrees. I minus 8 88 on both sides. I subtract 88 on both sides. Because of additive inverse, that goes away. 2a equals to 15 is 7 to 72. Okay. Confirm with your calculator. 360 minus 88. To 72 degrees. Divide both sides by 2. A equals to 136 degrees. So I will write 136 degrees and 136 degrees. So angle ADC equals to 136 degrees, and this is your answer. Now they want me to find CD. If this is 5 centimeters, this should also be 5 centimeters. Okay? If this, yes. So now I need to do Pythagorean Theorem to find CD. So I have my right triangle like this. I always just like to draw the triangle I am dealing with, so then I don't have to keep on going back there. So I know C, I know this is D, and I know this is T. And this is 8 centimeters, and this is 5 centimeters, and this is 90 degrees. So if this is 90 degrees, this is C. Small c. This is capital C. And if that is small c, I should use a pencil. If this is small c, this is A and this is B. So I use Pythagorean Theorem. I want to find C. I can either do C squared equals to A squared plus B squared, which equals to 5 squared plus 8 squared, which equals to 25 plus 64, which equals to 989. So C squared is 89. So then I have to find the square root of both sides. C equals to the square root of 89. Square root of 89 is 9.4 units. Or I just do C equals the square root of A squared plus B squared, and then 5 squared plus 8 squared, square root of 25 plus 64, square root of 89, which is 9 and 0.4 units. So it's up to you which of these two formulas you use. It doesn't matter. But draw your triangle so you see what part is missing. And remember, CD is the hypotenuse. Don't forget vocabulary. This is hypotenuse. And this is leg 1, or leg and leg. Remember that we learned in chapter 5. So the question was looking for the hypotenuse. You're looking for C. The answer you get must be greater than 8 and 5. They must be. Because we say the hypotenuse is the longest side in the right triangle. Okay. Do Aleph. See you tomorrow. Write your questions down, the questions that you have that you need to ask.